Hello, everyone. Hello. My name is Franck Le Ouay. I'm the co-founder and CEO of Lifen. So please come to the audience, please, to listen to this session. So I want to talk about AI-powered healthcare data. But first, Lifen is the company I started 10 years ago. We are based in Paris. We have about 160 employees today. And we develop solutions to help hospitals with day-to-day care delivery as well as clinical research. And the way we do that is by training AI models that read text, read medical notes, and understand the text and try to extract value from that. So we raised a bit more than 80 million euros in funding. So in clinical research, what we want to do is accelerate research thanks to AI-powered patient course, and I'll go more into details about why we think that is interesting. So, when you do clinical research, it always starts with data collection. You need data to understand care pathways, and the way it's done usually in studies is with manual processing. So you have clinical research associates, trained professionals, who open the files one by one, and they have on one screen the EHR, on the other screen they have the ECRF, and then they report the data. And well, it's the standard, it's the way it's done today, but as you know, it's quite tedious to do that. It's error prone, it's hard to have the same quality across different sites. Of course, it's very time consuming. Many sites don't have the staff to do that, so you have a question of how much staff do you have? Are they trained to do that correctly? Of course, it's costly, and will mention also the delay. So if you want to do that at scale, it's hard to have data rapidly available. So when we started working on this project 2 years ago, we asked ourselves, okay, can we try to automate that process, right? So the idea is we start from raw documents, just like you see here. So these are, clinical notes, exam results, tumor board summaries, etc. Everything that is contained in EHR files, and for the most part, it's just plain text. And we thought, okay, can we automate that process, and with what metrics? The way it works is we start from participating sites. So we approach hospital health centers and ask them if they want to participate in those studies. Then we collect the raw medical documents. We identify the data. So we run a tool locally that's going to selectively remove the personally identified data in the documents, so that we don't access the names and the last names and the address and the phone numbers and the emails and all that stuff, because we don't need them. And then we do the data structuration in the cloud, and therefore we can activate the data. We can use data for studies, dashboard, etc. One of the reasons why we do the data structuration in the cloud as opposed to on-prem, you might ask, there are two main reasons. The first one is we want to have the same algorithm running everywhere. We want to have the same rules, same algorithm, same models, and unless you run it in the cloud, it's very hard to do that in a multi-centric fashion. The second reason is that to run the latest and most powerful LLMs, you need big hardware infrastructure, and in many cases hospitals don't have access to those infrastructures. So if you want to have something that's going to scale and will not discriminate centers from one another, you need to have something that can work for everyone. So what we think automatic data collection will change, we think it can really be a paradigm shift in clinical research, because it solves a few problems. One, we believe that we can have a higher quality of data, and that quality will be by design, because it's the same rule, the same definitions, the same algorithm everywhere, the same quality control, Two, we think that we can build massive databases. You know, it's very hard to scale those databases by hand. We think we can, well, 10x, 100x, why not 1,000x number of patients? Why not have more variables per patient as well? And we think that we can, that's what we've started doing. We can include all patients, right? So we don't discriminate on the number of patients. We've run studies with very large inclusion criteria, so we can include lots of patients. And lastly, we think that well, we can also improve on the recency of data, right? So because the algorithm can run very quickly, so we can have data available almost immediately, which is important for oncology, where the standard of care changes so fast. So it all started with 2 years ago with a first partnership with Gustave Roussy Institute in Paris. You see Professor Bess and Mr. Macron, the picture here. So we studied a proof of concept on lung cancer, and now, as you will see, we have included 15,000 patients on the lung cancer cohort. We are starting new cohort, new indications today, pediatric cancer, prostate cancer, and we will continue next year. So if we zoom into the lung cancer cohorts, really the objective was to better understand the disease. So we work with a scientific committee that we describe here to define the variables that are meaningful to describe the disease, and describe the care pathway. And then we started working on the algorithms. We started recruiting patients first in this one center, Gustave Roussy, and then we expanded to other centers in France. So this is a brief summary of some of the variables that we structure. So demographics, risk factors, diagnostic, medical history, treatment. And then you see here the inclusion of the centers. The limiting factor for inclusion of centers is really the administrative work. It's not the algorithm itself. We really think that if we can potentially scale that to much bigger numbers if we decide to. Maybe a remark on the graph on the right. So we were able to recruit sites with many different profiles. So we have small sites, university centers as well. And we think that it's important to have a good representativity of patients and types of care. So more recently, we started to analyze the performance of the AI. So we ran a study that was in June this year. We took 311 patients randomly out of the whole cohort, and we asked 10 centers, can you please extract manually the data the way you would do it normally, and let's compare the performance. So the way we compared was so we did three arms, but when all the arms agreed, we assumed that the data was correct. So the manual structuration, the AI, and then the hybrid arm, we assumed it was the right answer. And when one of them at least disagreed with the others, we had an expert who came in and blindly decided, okay, which one is right, which one is wrong. And the results were very encouraging because we found that the AI arm performs better than the manual arm. And it performed better not just in average, but on each and every variable and each and every center. So that was a very encouraging finding. The second finding, which was kind of expected, was that there is less variance between sites, right? Because it's the same algorithm everywhere. We're expecting that, but we have a 3x reduction in variance between in error rates between sites. So there are lots of things we want to invest in. First one is we want to try the same kind of study in a multi-language setting. The first one was only in French language, so that would be the next step, one of the next steps. Second, in the first approach, we we designed the variables with clinicians and the way they do it usually. So we had a quite limited set of variables, but we think that we could capture much more granular data. So instead of having like 80 variables, why not have 2,000 variables, or having like a longitudinal description of all the all the variables? That would be much better. Where we think it could be much better. It's something that is not feasible by hand, but that AI can do. So we very much want to improve on that and to invest in that. And then, of course, there is a lot more work to do on improving further the accuracy and the confidence prediction. So maybe one just word on that. When the algorithm runs, not only it predicts the value, but it predicts a confidence factor on the value, right? So it says, okay, I am sure or I'm not sure about the value. And this is a separate algorithm that we can also tune. And we think there is a lot of value in understanding when the AI is sure, when the AI is not sure, because we can target quality controls in a better way. So what's next? Well, the sky is the limit. We want to, and we start to deploy more and more indications. We are having discussions to deploy in many countries. I studied countries where we have active discussions today. So, of course, we are happy to discuss if you are interested. So, why join the projects? Well, for centers, you can. It's free to join. You can access your patient's data unlimited. For pharma companies, of course, it's a new resource that can be used to secure and shorten time to market for new therapies, for having stronger evidence, and for physicians, academics. It's a new tool to run studies across lots of hospitals, lots of academic institutions. So we hope it's a win for everyone. So thank you for listening, and I'm open to questions if there is time left.
Thank you. I actually have plenty of questions. Just going to ask. So I think here the main bottleneck is you can use 20,000 variables, but to measure, let's say, how good is your algorithm to get structured data out from free text, you will have to have manually curated data, right? Do you envision any other intelligent way of actually measuring how your extraction of structured data from free text is working? I mean, because it's impossible to curate manually 20,000 variables. You also show I was very, very surprised in the scenario one, when you ask from the center, can you do it manually? The performance are very low, probably saying that, you can put a data manager, but you would eventually need a radiologist or a pathologist or an oncologist to really get this. So do you envision any, maybe, I don't know, training machine learning algorithm on these two types of data, looking at the explainability and if variables or performances are bad? Anything, that can help solving this bottleneck?
So it's a very good question. It's a hard problem, right? Because actually, when we ran the study and when we trained the models before running the study, we found it very hard to define the ground truth. What is the ground truth? Because you can always, well, first experts can debate for hours about is it answer A or B, but we kept finding that we were getting better at defining the ground truth, because also AI was improving and it was pointing things that we thought were true but actually were not true. So we had a very iterative process to improve data. I think it's an open question, really. We can try to benchmark based on clinical outcomes, for example. Okay, do we get the same PFS, or these could be interesting studies, but it's a very I would not be confident it's a very good way to qualify that every single variable is going to be okay. It's a way to validate that you're not wrong in aggregate. I think one other way to work on that is to have more granular data and data that is, I would say, more objective. Like, for example, data of diagnostic is very subjective because you have many factors, etc., as opposed to the performance status. Right? Performance status is very objective, right? So you can, and if you build aggregates, more complex variable based on more granular variables, maybe it's another way to have more confidence in lots of variables. I'm not sure if I covered everything. More questions?
Another one, a follow-up on that. I mean, the point is that do you really want to be perfect? In a sense that do we really want to reach 100%, or do we accept that, also because, let's be honest, training an AI algorithm, we will have to deal with missing data, inconsistency. So do we really, what's our reach goal, 100%, or do we set to be as mimic as much as possible the data we collect routinely? Because maybe the information might not be, might be controversial, it might be missing for many reasons, missing and random, not at random. So do we really want to reach 100%, or do we have in mind any other threshold that would be good enough?
Again, I'm not sure, not sure about the right answer. I think so. You don't know what's the minimum limit, right? So no one knows. But I think you can try to be. It forces you if you want to decrease the error rates, and we've seen that. So let's take a very simple variable. Let's take tobacco status at diagnostic. Very simple variable in principle, right? So you will get, 80% of the answers very easily. But the 20% remaining are, okay, the text is not very clear. This patient only smoked a few years when he or she was young. So, like you have everything, right? So, so it forces you, if you really want to train the algorithm and be consistent, to say, okay, what is the rule? What do I say in this situation, and try to implement those rules the best possible way. And then there will be cases where, okay, there are more than one possibility, and that's fine. So yeah, but I think the intent, we should have the intent of trying to decrease the error, because it's going to perform better in the end than manual extraction. And I think that's one of the goals, is to say, okay, if we remove the human component, or at least if we not remove it, but focus it on where the AI is not right, we can have databases which are going to be much bigger in size, and therefore be more useful for research.
Sir, how do you ensure uniformity in data collection? Because in one hospital, hello, yeah, sir, how do you ensure uniformity in data collection? Because in every hospital, every department wants a separate set of variables, some extra variables. So how do you kind of uniform the data to one data set? I mean, do you consult all the clinicians, or
That's a very good question. So we, that's part of the project. So we built a scientific committee that defines the variable for everyone. So it's the same variable. They can change over time, right? But it's a scientific committee that defines the variable for every center. So centers don't have a say about how they want the variables to be different. It's the same. And that's the value of the project. If they want to have their own variable, that they don't need us. They can do that internally with their own teams, right?
as far as I've seen in one of the slides, you are collecting data in new launching of the prostate cancer. So what kind of variables are being included in this study? And the question is that we are also feeding the AI. So we are putting the data. How can we overcome the errors from the AI being introduced by us? So the first question is the variables of the prostate, and the second, how can we overcome the errors?
Yeah, so there will be, there is a distinct scientific committee per indication, right? So depending on the indication, there will be different distinct variables, but we try to make sure that there is a set of common variables so that in the end, we will be able to run studies across these different indications when it matters.
How can we overcome the errors from the AI? I think when it's combined, it will be less incidence of the errors being for the data being collected. So we do the human resources. I mean, if we do the
annotation.
Yeah.
So I'm not sure I totally understood the question.
So it's either being human collected or it's being the AI, and if it's being combined, of course, with the incidence of the error will be decreased. So how can we overcome?
So when we train the algorithm, you mean?
Yes.
So when we train the algorithm, we are going to run the algorithm and then check with clinical research associate, verify that okay, do they agree with the AI, yes or no? And if they don't agree, then we will feed back this to the algorithm so that they can learn on that and improve over time. And that's how we improve performance over time.
Thanks for your great work. And I was wondering that you collect like clinical notes, reports, and all the other free text, unstructured data, right? And so when you feed it into the LLMs and do the structured output, what did you find anything that is more influential? Like, is the clinical notes more influential, or the reports are more influential towards the variables you collect?
I don't have a specific study on that. I would say sometimes you might just have like one document about like tumor board, which is very complete, and you get lots of data. It's very dependent on the case. But yeah, no, I don't have specific data on which kind of report is the most important.
Because sometimes the clinical notes or the reports, they are redundant. Data.
But yes, they're highly redundant. They're highly redundant. So that's good in a sense, because even if you're missing one document, you may recover from the redundant data in many documents. Yeah.
Do you do the like notes we generate from day to day? There will be like repeated. We will copy the past notes to the present notes and then make little changes. And do you make any like data engineering from the notes, or we just take every unstructured text data?
We just take everything. We take everything that, that there is. Yeah.
Thank you.
Hi, thank you very much. My question is on the output data. How are they structured? I mean, do they follow a common data model so that it's like more interchangeable? I mean, even among other consortium, or are they, I don't know, how are they structured when they are output?
Yeah, again, good question. We haven't worked too much on that. There are a few common data models like OMOP and that are often mentioned. We don't support that today, but we will in the future. It's just a matter of time to work on that.
How are they now? I mean, once they are collected, do they look like, I don't know, an electronic CSV or an Excel file?
Yeah, it's more like a CSV file than... but it works.
No, because, I mean, in the way of making data more interchangeable and all of it, probably
Yeah,
a
I agree.
common data model would be the best, even because they are linked to ontologies, so they end up
I agree.
being more
And we,
reproducible.
yeah.
Okay, thank you.
Well, thank you.